This is Redox video number 6, electrolytic cells. This video we're going to talk about non-spontaneous redox reactions. These are what occurs in an electrolytic cell. So I remember that electrolytic cell begins with an E and ends with a C. So in electrolytic cells we are converting electrical energy to chemical energy. So this is different than the voltaic cell, because the voltaic cell we had a chemical reaction, redox reaction happening, and that converted electricity spontaneously. Here, this is not spontaneous. So since it's not spontaneous, you need electricity. So in any electrolytic cell, you will see this is a symbol for a battery, or there'll actually be a picture of a battery. That is the giveaway that the cell is electrolytic. It requires electricity to force a non-spontaneous redox reaction to happen. So that's like one huge key difference that we need to know for electrolytic cells. And here everything is kind of going to switch. So since they require energy to happen, our anode and cathode are going to switch places. So instead of the anode being the one higher up on table J, now the anode is going to be the one that's lower on table J. Also, the charges of our anode and cathode switch. So now instead of the cathode being positive, now it's negative. Instead of the anode being negative, now the charge of the anode is positive. So this is not normal or not natural. That's why it needs the battery. The battery forces the electrons to move in a direction it doesn't want to move. Okay, so it's always good to talk about real-world application. Why would we want to know about electrolytic cells? Well, there are a couple things. We could electroplate something, which is where you plate the surface of a metal with a material. So for example, if I had a plastic spoon and I wanted the plastic spoon to look like silvery, I could electroplate it with a silver surface. And you've probably seen that before, like when you've gone to a party or something, it's not real silver that they're using. They're using maybe materials that have been electroplated. You may have also seen these on things like kitchen cabinets, faucets, cheap jewelry. Sometimes plastic things have been electroplated. Sometimes there's a reason, like maybe they're electroplating to prevent rusting or to increase strength, something like that. Like, here's another picture of an electrolytic cell. Notice there's a battery. The battery will show you, again, is going to force these electrons to move from the anode to cathode. Copper is the anode because it's lower on table J. Zinc is the cathode because it's higher on table J. Remember, it's the opposite of the voltaic cell. Electrons will still move anode to cathode. So it still goes anode to cathode. It's just that the battery forces the electrons to move. If you notice, the positive end is the anode. The negative end is the cathode. The positive end of the battery will be attached to the anode and negative attached to the cathode. But for the most part, the way that you're going to see application of electrolytic cells is an electroplating system. That's how the Regents most commonly uses it. So a couple of things for you to keep in mind. One, you don't need two separate cells. It could all happen in one cell, like one beaker or one container. If you look at this example, this is silver, a bar of silver, and what we're doing is we're electroplating a spoon. So we want this spoon to appear silver colored. What's going to happen is the object will always be the cathode. So if you know, we'll just label that, the object. It could be a spoon, it could be a fork, it doesn't matter what it is, but the object is the cathode. And here the cathode is negative because we're talking about an electrolytic cell. So we have positive silver ions in solution, and they're going to be attracted to that negative cathode and will be reduced at the cathode because we still have red cat, reduction at the cathode. Those ions are reduced and become solid silver, Ag solid. So they go from +1, they gain an electron, and they become Ag0. When you're 0, you're a solid. So little solids will deposit along the spoon in the form of silver, so the spoon will actually look silver. So we're going to electroplate tomorrow, and we'll look at making a solution appear copper colored, where copper ions will be attracted to whatever object it is that we want to electroplate, and they'll be reduced at the cathode, which will be your object, and you'll see copper solid deposited on your object. So whatever is your object in the electrolytic cell is the cathode. The charge of the cathode is negative. That's different than the voltaic. This can happen in one beaker, and whatever is your metal here is your anode, which is positive in this cell. So key differences here we want to know is that this is non-spontaneous. Notice the battery. Notice that the charges of the anode and cathode have switched in this case. But our acronyms will always hold true. Those don't go away. Those work for everything. So anox still holds true. We're still having oxidation at the anode. Red cat, yep, still having reduction at the cathode. We still have electrons go A to C, anode to cathode. And Leo and Gur, like loss of electrons is still oxidation, gain of electrons still reduction. All that's happening is you're providing electricity to force a non-spontaneous reaction to occur. And then the charges of the anode and cathode are switching places. And then there'll be some questions that will ask you about what kind of ions would be attracted to the cathode. Well, here the cathode is negative, so keep in mind that anything positive will be attracted to the cathode. The anode is negative, so anything that's positive, the anode is positive, so anything negative will be attracted to it. Here's another picture of an electrolytic cell. Same idea. This is one solution. Copper ions are being attracted to a key, so we're going to make the copper appear, copper colored. The key is the object. The object is the cathode. And here the cathode is negative, so we have positive ions are attracted to it and will electroplate or coat it in a copper color so it'll appear copper. Here you have the copper anode. Again, just one beaker. Notice the battery. The negative ion is attached to the cathode. The positive ion is attached to the anode. Another application of an electrolytic cell is electrolysis, which is where we're taking water and you're applying electricity and trying to split it into hydrogen and oxygen. So this is just a picture of this happening. But sometimes they'll ask what would be an application of electrolytic cells, and that's electrolysis or hydrolysis. So in closing, I just want to summarize real quick a couple of differences between voltaic and electrolytic cells. Voltaic cells produce electricity. Electrolytic cells, they need electricity or electrical energy. Voltaic cells have to have two different metals, which are not the same, in two different solutions, whereas electrolytic, they can happen all within one solution. And we should also know that the charges of the anode and cathode switch. So in the voltaic cell, we have the anode is negative and the cathode is positive. And here it's going to be the opposite, where the anode is positive and the cathode is negative.